Okay, hi, so in this video I'll explain how to do this question of finding first partial derivative for this function that depends on two variables, the u and the v, right? So before that I'll need to introduce a few concepts. So for example, right, function hx, right, equals to 3x squared plus x. So when it's h3, right, it will mean that if it's 3, then the x will be substituted with 3, so we have 3 squared plus 3. So this is how a function works. What about functions that depend on two variables, so u and v? And so if we have like u square plus v square, something like this, when we have h 2 3, what we are going to get is we are going to substitute 2 into the u, because 2 is taking the space of u, so 2 square plus 3 square, and then that will be how a function that depends on two variable works. So suppose, right, and another idea, right, if when we differentiate, let's say differentiate h with respect to u, then when we are doing that, then v is just like a constant, so I'm just going to differentiate the u square, which will give me 2u, and when I differentiate v, I treat it like it is a constant, so it will be 0. However, when I do a partial derivative with respect to v, then u is like a constant, so we will get, when we differentiating this function with respect to v, u square is just a constant, so we will get 0, and then when we differentiate v, we will get 2v. So these are some concepts that we need to have. And then the other idea is that there's this idea that when we have log ab, right, that means when we log a function a to the power of b, it is equivalent to b log a. And then there's another idea that when we differentiate a function, log function fx, right, what we get is equals to f prime x over fx. So let's see how it is all these concepts are applied to this question. So firstly, because h u v equals to this, right, so when I partial, okay, so it is, in other words, using the log rules, right, and then also, okay, because another concept is that when we root something, it is the same as writing x to the power of half, right? X to the power of half is the same as root x, except that it is written, one is the third form, one is the power form. So in this case, because there's a root over u square minus v square, so we can rewrite this as u square minus v square to the power of half. And then looking at this, when apply this rule over here, because the power half can be bring in front, so that's just like this power b can bring in front of the, so we'll write this as half ln u square minus v square instead. This makes it easier to do the differentiation, although there are other ways to do it as well, but written in this form is easier to do the differentiation. So when I do a partial derivative with respect to u, I should be treating the v as the constant and the u as the variable. So using the constant multiple rule, the half, right, I will bring in front, and when I using the rule here, this ln fx, f prime x equals to f prime x over fx, so I'm going to differentiate this with respect to u, which will give me just 2u, then minus v square will just give me 0 here, and over the u square minus v square. So this is what I will get. Okay, because using the rule over here, right, I'm differentiating this with respect to u, and I get 2u. When differentiating a constant, I get a 0, and then over the u square minus v square, because you see I'm over this, right, the f prime x stands for the derivative of fx. So when I differentiate a logarithmic function, I get the it becomes the differentiation of f prime x over fx. So that is how it is done. So to simplify, this becomes u over u square minus v square. What if we partial derivative with respect to v instead? When we do that, right, we have this one, the constant multiple rule will still be in front. Then when I differentiate this, u square is a constant, but because I'm differentiating with respect to v, so u square is a constant, so I get, when I differentiate minus v square, I get minus 2v, and then I'll keep u square minus v square in the denominator, right, just by applying the rule here. So I get minus v over u square minus v square as the final answer. Right, I can rewrite it as, because the minus sign, the minus v, to make it like look nicer, right, I could bring the minus down, and so I get v over v square minus u square. So that is the difference when we partial derivative with respect to v and when we respect to u. Right. So because for this video there are some prerequisite. This is a polytechnic maths. So students are already expected to understand the basic differentiation and the differentiation of the logarithmic function. So I'm going a bit fast over here. So other than that, yeah, that's it. Feel free to ask me questions in the comments.